A 140 kilogram horizontal beam is supported at each end. A 320 kilogram piano rests a quarter of the way from one end. What is the vertical force on each of the supports? In this diagram, let lowercase m be the mass of the beam and capital M be the mass of the piano. In order to determine the net torque, we need to identify the axis of rotation and the length of the lever arm. At the left support, if the left corner of the beam is the axis of rotation, the length is 0. At the mass of the piano, the length is L divided by 4, but the downwards force would rotate it clockwise, giving it a negative torque. The same applies to the force of gravity on the center of the beam. The support on the right has a full length L and it pushes up on the right side, rotating the beam counterclockwise, giving it a positive torque. Because the system is in equilibrium, the net torque is 0, with torque being the force times the length of the lever arm. Since the torque at the left support is 0, we can solve for the force at the right support. The L's cancel out and you are left with the force on the right equaling half of the mass of the beam plus a quarter of the mass of the piano times G. The sum of the forces in the x direction is 0 because nothing is moving left or right. The sum of the forces in the y direction is the force of the left and right supports up on the beam, which is positive, and the force of gravity at the center of the beam and of the piano on the beam pushing down, giving a negative force. Solving for the left force then gives you 3.04 times 10 to the third newtons. These are the forces of the supports on the beam. So the forces on the supports are equal in magnitude and opposite in direction to the above forces.